Let x1, x2 and so on xn be a random sample from uniform 0, theta. T1 is 2 by n summation xi and T2 is maximum order statistic. So we are given that x1, x2 and so on xn follows uniform 0, theta, and T1 is given as summation I is equals to 1 to n xi into 2 by n, and T2 is given as maximum order statistic x1, x2 and so on till xn. So if we find like x, so x is following uniform 0, theta, so expectation of x is nothing but theta by 2 and variance of x is theta square by 12. So if we check like T1 is nothing but 2 times of x bar, so expectation of x bar is theta by 2, so that means expectation of T1 is 2 times of theta by 2, which is theta. So that means T1 is unbiased, whereas if we consider the variance of x bar, so the variance of x bar is nothing but variance of x whole divided by n, which is theta square by 12 times n. So variance of T1 is equals to 4 times variance of x bar, which is 4 times theta square by 12n, which is theta square by 3n. So as n tends to infinity, we can notice that variance of T1 tends to 0 and expectation of T1 is nothing but theta. So therefore T1 is consistent. And if we check for T2, so T2 is the maximum order statistic like x1, x2 and so on xn. So that means the distribution, so f T2 of t is nothing but t by theta whole to the power of n, where 0 is less than t is less than theta. So expectation of T2, so that is nothing but n by n plus 1 theta, which is not equals to theta. So therefore T2 is unbiased.